In this video I want to demonstrate the working of the converter, the Adc 42 in Visual Basic. The Visual Basic I have used the version 6.0. This is the interface initial interface, and is possible to make a standard executable application. The application, the program, is saved in the disk with the name NDL, and I open the application, the program. This is the form, the prototype form, with the labels and the box text, and like we can see, the ADC info, drive version, the samples by seconds, direct reading, and writes the start, stop, and the volts. In direct reading, in the box direct reading, we can see the information from the converter, and the direct information from the converter. In the box from the box with the name volts, we see the number converted in volts. This is a part of the program, list of the program, with the variables, the declaration of the variables, ports, the public port, public N, in the declaration of the ADC10 open unit. This is the important procedure for open the converter. ADC10 open unit, we can open the converter and prepare the converter for receive information from other sources. Here we can see the model when you declare the functions and all the usables drivers, the get driver, open unit, set unit, etc. Now is the program working with all boxes clear, and when we click in the start, we can obtain the ADC information. ADC 42 is connected to LPT1. The driver version is 2.1, and the converter receives samples at 11627 samples by second. The direct reading is the number 2053, is a number between 0 and 44. I don't remember now, but I can see in my papers. Yes, is the number from 0 that correspond to 5 volts, In the middle we have 2048 that correspond to 0 volt, and the big number 4095 that correspond to minus 5 volts. The number 2053 is very near from 2048, and this is meaning that is 0 volts. We can see in the volts 0.01220. That is a small voltage. Here in this slide, what you see is the same information, but I have connected a small battery, nickel cadmium battery, chargeable nickel cadmium, that correspond to 1.38 volts, and the direct reading is 2615. If I invert the polarity of the battery, we can see minus 1.37 volts that correspond to 1486 is the direct reading. And that's all for demonstrate the working of the analogical digital converter.